Chapter 9, 909, the cosine rule. The cosine rule is a relationship between the three sides of a triangle and one of its angles. It is an extension of Pythagoras' triangle that can be applied to any triangle, not just right-angled ones. For any triangle ABC, a squared equals b squared plus c squared minus 2bc cosine A, where A is the unknown side, capital A is the angle opposite A, and B and C are the two other sides, or the other two sides. Okay, so here's the proof, and we construct. Now remember, this is any shaped triangle. All right, and what we do is we drop this altitude down here, and we make a right angle triangle here and a right angle triangle there. And then they use Pythagoras' theorem on this triangle, the smaller one, and on this one. And they equate them through this common h. And also, look, this distance here is broken up into c minus x and x. So it's quite a good proof, pretty straightforward. So that's something to read through there. This is important. The cosine rule can be used in problems involving three sides of a triangle and one of the angles. Example 21, find x correct to two decimal places. There's a triangle there. It looks like a right angle triangle, but it's not a right angle triangle. But what we have here is an included angle. That's called an included angle. It's included between those two sides there. So this is a straightforward cosine rule question. It's also in the section where we're going to practice cosine rule. So we're obviously going to use the cosine rule. Now the cosine rule, a squared equals b squared plus c squared minus 2bc cosine A. And it works out pretty well because x is the unknown. So it's x squared equals 2.1 squared plus 3.9 squared minus 2 times this times that, and then cosine of that. And then we get an answer, but be careful here. That answer is still x squared, so you have to take the square root of that, which they've done here. They've got that to two decimal places. That's the answer there. Also, that's important. From the diagram, an answer of 3.02 centimeters looks reasonable, so you kind of make a judgment there. This is the largest angle, so that's the longest side. And about 3 centimeters, that looks okay. Okay, exercise 9-09, the cosine rule. Solve each equation for x correct to one decimal place. Okay, again, pretty straightforward, like the example. That's like the example there, and that's like the example as well. Find correct to two decimal places the value of each pronumeral. Okay, there it is again, very much like the example. We know this angle and the two sides, so that's an included angle between that side and that side. We can find that. Here, that 145.1, well, let's say it's this angle in here. Obviously, it's a larger angle. It's an obtuse angle. So that one is that angle there. That's also obtuse, so it's that one. That angle. Okay, so all pretty straightforward. This one, you need to put, for some reason, they don't have a pronumeral here. You put an x there, and you can solve that. Okay, and this is in minutes here as well, and that's in minutes, so change it to a decimal, unless you can put it directly in the calculator using minutes. That's going to be 77 degrees and 22 over 60. Yeah, 22 over 60 becomes the decimal part, right? Good, and also note here the pattern. You got 8, 8, 9, 8, 9, 11.3, 9.7, 11.3, 9.7. So there's definitely a pattern in this formula. It's in the formula booklet as well. Okay, some interesting questions here. Okay, just looking at the diagram. Again, that's the included angle. It is in minutes as well. You'll have to put that either directly in the calculator as degrees in minutes, or that would be 15 divided by 60. So that's going to be 2.25 degrees. That's an included angle. So if you read all that, it's possible they're going to ask us that distance, right? And let's see. How far is his bowl from the jack? Yeah. So they're asking for that distance, so we're going to use the cosine rule. This one here in a cricket match, the distance between the bowler and the batter is 20 meters. So we know that length. Again, it's the same, right? That's an included angle, 8 degrees. So they're asking for that distance, D. Let's see the line of the pitch, and the bowler ran and caught the ball after it travelled 18 meters. Yeah. How far did the bowler run to catch the ball? So he's going to run from there to there. It's an A, B, C, D question. Wow. Okay, so that's also just D squared equals 20 squared plus 18 squared minus 2 times 20 times 18 times cosine of 8 degrees. Okay, and some more interesting questions here. A yacht sails from X to Y on a bearing. So they often put these questions with bearing in the test. Bearing questions, remember, when you have a point in a bearing question, you always put the north in. Just put the north in directly there. So it's sails from X to Y on a bearing of 130. So that's 130 there. So the bearing is that angle. So it goes from there to there at a bearing of 130 for 4.2. We know that's 4.2. So you're going to have to start labeling everything up. Put 4.2 here. Also, that angle is 130. Okay, angles put in as well. It then turns and travels to Z on a bearing of 25 degrees. Again, you put the arrow straight up. It's a 25 degrees. So the 25 degrees is from the north to here. That little part there is 25 degrees. And we know that length there is 2.9 kilometers. Okay, so we've got this one. We know that length. We know that length. We know that little piece in there. We know this is 130 to here. So this part here, if you continue that down this way, this part here is going to be 50. Well, remember, angles in parallel lines, if that's parallel, then if that's 50, then that's also 50. So this angle would be 50 plus the 25, so it'd be a 75. And so we know that angle, we know that, and we can find that distance. And that's what they're asking for here to 1 decimal place. So make sure you label it up as you go through the question there. This is also a good one, probably a little bit easier than number 5. 3 towns are joined by straight roads. What distance correct to the nearest kilometre is saved by going directly from Springfield to Shelbyville? So going that way rather than going this way and that way. Well, we've got the included angle. We just need to find that length. But remember, the question's interestingly asked here. It says what distance is saved by going directly. So when you add up those two, and that's 285, you then minus it from that. So the answer is not that length. It's 285 minus that length will be the answer, right? What distance is saved, because that'll be a quicker distance than 285. And question 7, what is the value of cosine 90? Don't use the calculator, just think about the unit circle again. Cosine's measured on the x-axis, 90 degrees. Remember, on the unit circle, we use the positive x-axis in an anti-clockwise direction. So cosine of 90 is straight up because it's this angle up to there. And if you think about it, if it's directly up, it has no value on the x-axis, it's 0. So cosine of 90 is 0. And then it says, what does a squared equals b squared plus c squared minus 2bc cosine a simplified to if a equals 90? Well, if cosine a is 0, or cosine 90 is 0, then a squared equals b squared plus c squared. Hence, what happens to the cosine rule when it is applied to a right angle triangle? It becomes the Pythagoras theorem.